Hi, we are going to show us how to design a reactor for a process of methanol production, and our team are formed by Aranza San Vicente, Edson Omar, Francisco Olvera, Santiago Alberto, and Alisa.
First, we are going to explain some characteristics of the methanol for all to understand. As we can see in the picture, this molecule is formed by 4 parts hydrogen, 1 part oxygen, and 1 part of carbon. As we can see, this molecule belongs to the group of the alcohol. Well, this molecule is also known as methyl alcohol or wood alcohol. I'll explain why in a few moments. Other characteristics are that it is a clear liquid chemical. It is soluble in water and it is biodegradable. Well, the freezing point is at minus 97.6 Celsius degrees. The boiling point is at 64.6 Celsius degrees and has a density of 791 kilograms per cubic meter at a temperature of 20 Celsius degrees. Methanol is used to produce other chemical products that live among us, such as building materials, foams, resins, plastics, paints, polyester, and a variety of health and pharmaceutical products. Also, it has been used to create a biodegradable fuel since it has a lot of environmental and economic advantages. It is used as an alternative fuel not only for cars but also for powering ships, cooking food, and heating homes. Well, in this part, we're going to talk about how this methanol is obtained. In the past, they obtained methanol from distilling wood. This was a successful source in the region if it was fully stocked with wood. But nowadays, we obtain methanol by a mixture of natural gas, that is carbon monoxide, and steam, that is hydrogen. The mixture is first heated and then passes over a catalyst and a steam reformer. Then this steam is transformed into a synthesis gas and then is pressurized and converted to crude methanol. Finally, it is distilled to remove water and yield pure methanol. Well, this gas preparation will be the one with the highest cost since the 60% of the process is focused in this phase. Well, my teammates will explain this with more detail. In the slide, we can see at the right part, we can see the reaction of the production of syngas and the catalyst used while the reaction. And we can see the reaction also for the production of methanol and the catalyst used in each reaction. Also, a world-scale methanol plant produces 5,000 metric tons per day.
Normally, the reaction occurs at a temperature of 300 and 400 Celsius and a pressure of 200 and 300 atmospheres. The catalysts used are the zinc oxide or the chromium oxide. The synthesis gas, raw material, can be obtained in different ways. The different production processes differ from each other, precisely because of this fact. Currently, the most widely used process for synthesis gas is obtained from the partial combustion of natural gas and in the presence of water vapor. The catalyst used can be chromium oxide or zinc oxide, as I mentioned it before, and the price per ton in the case of the zinc oxide is between the $2,000 and the $2,500, and for the chromium oxide is between the $4,200 and $5,000. There are 3 main reactions for the formation of methanol from the synthesis gas. The reactions is made of hydrogenation of carbon monoxide and hydrogenation of carbon dioxide and the reverse water gas shift reaction. The reaction proceeds as follows. First, we have the carbon monoxide plus 2H2CH3OH and have a delta H of minus 19.8 kJ per mole. Then we have the second reaction, that is the carbon dioxide plus the hydrogen, that gives us the methanol and water. And the last one is the the carbon dioxide plus hydrogen that give us the carbon monoxide and water. It's important that these reactions are reversible reactions.
Talking about the reactor, our assumptions are adiabatic system, perfect scale, mechanical simplicity, and low cost. These things we can achieve with a CSTR. In the next reactions, we have a natural gas, syngas, methanol synthesis, and direct oxidation. In the natural gas, the syntheses are prepared and compressed typically accounts for 60% of the investment, and almost all energy is consumed in these process sections. In the syngas is a general term describing a mixture of hydrogen and carbon dioxide. In different regions can be generated from any hydrocarbon feedstock. The production of syngas occupies the major investment on the cost plants. In the direct oxidation, we know that the ware methanol mixture is distillated in order to meet the final specifications. It is essential for methanol to be stabilized in order to remove volatile compounds such as dioxide of carbon and permit shipment and transport in atmospheric vessels.
The heat transfer in the methanol synthesis is one of the main factors that we have to take in account when we are designing a process like this. This is due to two main reasons that we must take in consideration when we are designing a methanol production process. The first one is the temperature at what our reaction occurs. The catalytic reaction we are using for our product takes place at 3 to 400 Celsius degrees. So we must have a very good heat transfer in our process in order to achieve the products that we want. The second thing that we must take in account is the control of the temperature in our reactor. If we do not have a good control of temperature, we may be producing undesired product and not the methanol we want. So we must have the possibility to not just heat the reactor, but also to remove the excess of heat. From that basis, we have to be very smart when we choose the materials of our reactor. There are several options in the market. The most popular may be the inoxidable steel, but we have to take in account that methanol can be corrosive in the presence of steel. So we have to look for another option. A good choice for our reactor is the alloy 625, which is an alloy of nickel, chrome, molybdenum, and niobium, offering us a very good corrosion resistance and a high temperature operation without wear out. Say that, the main considerations about heat transfer and materials that we have to take in account for our process are: the first one, a material that helps us to reduce the spatial variation in temperature to zero. The second one, use materials with a very good heat transfer capacity. And the last one, use materials that do not wear out with high temperatures or corrosions.
Well, the methanol is very important because it's not just for energy production. You can use in other part of the industries, and this is important because in the future it can be a very important component for getting energy and getting another things like the plastics. So this is our presentation. We are hope that you enjoy it. There are some reference that we obtain the information. Thank you.